Hello, thank you for coming. My name is Steve Judd. I work for a company called JetStack. Some of you may be familiar because we produce Cert Manager. I work on the other side of JetStack, which is the consulting and training division. And a lot of what I do is I spend quite a lot of my time evaluating Kubernetes tools and kind of new ways of using and abusing Kubernetes. As a result of this, I end up creating and destroying a large number of Kubernetes clusters on a tediously regular basis. And that's great because there's plenty of cool tools out there for creating those sort of clusters. I happen to use GKE as my distribution of choice, but equally could apply to any type of cluster distribution. But the thing is, once I've got that cluster up and running, and I tend to use Terraform to do that, which is fine, and I've now got a vanilla cluster, and it's got a little bit installed on it. It will probably have kube proxy, it will have DNS, it will have networking. But I tend to then want a bunch of my favorite cluster add-ons. So I want Cert Manager, I'll want Nginx, Ingress, I'll probably want Argo CD. And how do you get from that vanilla cluster over to your ready-to-go cluster? So that's kind of the problem that I'm going to be talking around for the rest of this session. So appreciate my use case is pretty trivial, but equally, if you're a platform team and you're responsible for provisioning large numbers of tests and development clusters and production clusters, and you want those to be consistently provisioned and all appear with a nice set of standardized add-ons that you want, then this could equally apply to you too. Okay, so few solutions up here, not necessarily all of them, but these are the ones that I'd kind of tried. So running scripts manually, hell yes. So that's where I started off. Got a few bash scripts rocking. Then I kind of moved into makefile targets. Running my Helm kind of applies in various formats. That's okay. And talking to a lot of the clients that we work with, that's kind of where they're at, and they're still doing this with their run books, and they kind of bring it up and they're typing away. But obviously there's some issues with that. You've got the kind of manual nature of it, the opportunity for fat fingers screwing something up, and so on. There are various Terraform providers that you could also use. So I've listed 3 of them up there. I've tried them all. Going to be honest, I'm not really a fan of using Terraform to manipulate resources in my Kubernetes cluster. Terraform is not a golden hammer, I feel. And more importantly, it creates its own state file with the state of what it thinks your cluster's in. Now you've got 2 states. You've got the Kubernetes API state of your cluster, and you've got the Terraform state, and inevitably you're going to get some level of drift. So that's why I'm kind of uncomfortable with using Terraform, although inevitably it appears somewhere, as you'll see later on. So the one that I'm going to focus on is the bottom one, the GitOps approach, using something like Argo CD or Flux. They work broadly similar at quite a high level. I think one of my someone I met at this conference explained it to me. Flux has got a great API but a crappy UI, whereas Argo CD's got an awesome UI, less so on the API. So I'm going to go with that kind of useful way of thinking of the 2 products. But to be fair, we've used both in JetStack. They have their fans. Both of them are great products. So how many here have used Argo CD? Awesome. So there will be a few that haven't. Excellent. So I've got a bit of a demo on Argo CD. In fact, I've got 2 demos. So I thought I'd sort of raise the stakes in the sort of demo area in this conference, so cross your fingers. So Argo CD, it's an operator and it runs in your cluster, and basically it's responsible for installing and managing applications in your Kubernetes cluster. And it does this by talking to Git repos where you store your manifests. Those manifests could be stored as raw Kubernetes manifests. You could store them as Helm charts, customized templates, and I think it also supports JSONet. So what happens is that you define, so the unit of work in Argo CD world is an application. So they have a CRD, and you use that application CRD to define where it should pick up these manifests, where the Git repo is, what folder, what branch, whether you want it automatically synced, and whether there's a few other kind of configurations, but that's the main kind of crux of it. And then the idea is with Argo is that it will be constantly, when it knows about your application, because you've given it one of these CRDs, it will be constantly monitoring that Git repo so that every time you push a change into the right branch, Argo CD will notice it, and it will take that and it will figure out the desired state from what you've provided in the Git repo. It will compare it with the actual state in the cluster, and it will try and reconcile those. So that's, in simple terms, what Argo CD is all about. So I thought now would be a good time, now that I've warmed everybody up, to do a bit of a demo. So let's see if this works. So what I've got here is, hopefully this will kind of be a bit visual. So I'm going to do cat. Can you see that all right? So on here is basically a very simple Argo CD application CRD. So you can see that you've got the source definition here, and it's pointing to a Git repo, and there's a particular folder in there that it needs to look at, the Hello World folder. And the sync policy down here is basically set to automatically sync it. So if I now, so I can just quickly show you what the manifest folder is. Basically, it's just 3 bog standard manifests. So if I do KCP apply, so I've now created the CRD in my cluster. So if I now go and have a look at the Argo CD desktop, and there you go, you can see in the middle there, you've got the Hello World application, and it's starting to, so Argo's already recognized that the application's there, and it's starting to synchronize that with the cluster. So if I go into that application, you can see that it's starting to apply that manifest. It started to create different resources in there, and in fact, it's finished really. And the only one that's not quite ready is with the broken heart is the certificate. So I'm creating an HTTPS connection, and Cert Manager's doing its thing, and it's talking to Let's Encrypt to get my certificate. So that, in a very quick few seconds, is basically Argo CD, and you can be wowed by the UI. So that's cool. So you can see how Argo CD could be used for deploying applications into your cluster. And normally those applications, they consist of, Kubernetes resources. But of course, they don't need to be just your bog standard Kubernetes resources. You could apply an application that also applies further application CRDs. And that is the crux of Argo CD's app of apps pattern, which I have attempted to describe in this diagram on the screen. So the idea is that you have a bootstrapper application, which is basically an Argo CD application, and it contains a list of other Argo CD application CRDs. So in my case, Cert Manager, Linkerd, Nginx Ingress, and Prometheus, and it's those child applications that actually point to, if you like, the real manifests. So that then means, because Argo CD is responsible for synchronizing all of this stuff, is that if you give it the Bootstrapper application CRD, it will then install the other applications, those listed there, which will in turn tell Argo to go and install Cert Manager and Prometheus. So that's the crux of the app of apps pattern. So on the screen here is an example of the Bootstrapper application manifest. So down the left, that's the actual CRD itself. So this particular one is using a Helm chart, and I've got a bunch of values down there. So I actually have a large number of potential applications that I want to install, and I just use booleans to tell the applications Argo CD which ones that I really want to be installed. And then on the right hand side you can just see a list of all the different manifests for all of the application CRDs. Okay, so hopefully that gives you part of the puzzle. You've now got a way of automatically installing a bunch of applications in your cluster once you've been able to get Argo CD into that cluster first. So of course that means you need to bootstrap Argo CD itself. How are we going to do that? And where this becomes kind of a bit of a challenge is I'm picking this stuff up from a private Git repo. So not only do I need to install Argo CD, I need to provide it with a secret that contains the GitHub access token. So somehow I need to do that. And then once Argo CD is up and running, I also need to give it the Bootstrapper application manifest. So there's a few things that need to happen there. And actually, it's really helpful to do those in the order that I've put there. Reason being that if Argo pops up before you, or rather, if you try and apply the Bootstrapper application CRD before Argo's there, then the Kubernetes API gets upset. And if the secret's not there and Argo CD kind of gets upset, and you just get errors and it just gets kind of tedious. So having a way of doing it in a nice order is really helpful. Okay, so that's kind of the problem. So how might you solve this? So this is what I use. So one of the plugins I discovered for Helm is something called Helmfile. And what Helmfile does is it allows you to specify installing a bunch of charts, but as a series of steps, or what they call releases. And you can say, step A, do this chart, step B, do this other chart, and you can specify that step B can only start when step A has finished and has been successful. So that's a way of kind of forcing, if you like, an order of events to happen. And I also use something called external secrets operator in order to grab my GitHub token from my secret manager and create a secret in the right place for Argo CD. So those are the steps that take place, and that is the order in which it happens. So this is an example of a fragment of my Helmfile manifest. So you can see at the top, the first step is installing the external secrets operator. You've got this wait true, which basically means that step won't successfully succeed until the operator is reporting a ready status. And then the second step is the thing that basically tells external secrets, go and take this secret from my secrets manager and create this secret. And that won't happen until the step before succeeds. So that's great. That gives me the next step. But then, hey, how are we going to bootstrap? How are we going to install Helmfile in my cluster? Because still got to do that bit. And can it be automated? So this gave me an awesome excuse to go and write an operator, because I'd not done this before, and I thought, ooh, I can write an operator. First of all, I had a look, actually. I did go and have a look, and Helmfile does have an operator, but it's quite old, and it's not maintained, and it looked super complicated, and it was written in Go, which is not really my first language. And I was like, this doesn't look great. And then I discovered that this company called Flant have created something called the shell operator, which genuinely I think is awesome. Although people I speak to go, you're writing an operator in Bash. What the hell, are you mad? So, but it is actually a very good operator, or I find it so. For the sorts of proofs of concepts that I tend to get involved with, I think writing 30 lines of bash that can go and watch a set of events and react to those events is perfectly acceptable. Other people may disagree, not quite sure whether you'd want to put it in production, but so that's what I did, and that's basically what this bash script does. So I've written it's about 30 lines, and I just tell it to look for a particular set of events. So I've created a Helmfile CRD, and it watches for a CRD appearing in the cluster, and then what that CRD does is it says, here's the Helm file. And then the operator takes that Helm file and it uses Helmfile binary that's within the image to go and execute that helmfile.yaml file. So that's kind of the components that Helmfile operator requires. So as I said, I've got my own Docker image, which is based on the Flant shell operator. The reason I've got my own image is because I need a couple of extra binaries. So I need the Helmfile binary, and I also use JQ. So as I said, I've got the Helmfile CRD, which literally just has, I don't know, about 3 different configuration parameters to specify the Git repo where it needs to get the Helm file from. So then you get the helmfile.yaml, and then finally you've got the bash script that actually gets executed, and rather than bake that into the Docker image, I just get the pod to go and read the bash script out of a config map. So yeah, that's in essence what my operator does in bash. So I'm going to do a demo, but not of it actually going ahead, because that kind of takes a few minutes and it's not necessarily that interesting. But what I will show you is some of the elements that get created. So let's see, did I want to do that? Let's go back to here. So in my so I have a namespace called bootstrapped.init. That's where the operator lives and the Helm files. And basically those are all the components. So the kind of important ones, you can see that that's where the config map with the actual bash script is. You've got a secret that's got a GitHub token to go and get to my to get to my Git repo. Then you've got the pod that's running the operator, and then at the bottom you've got the Helmfile CRD itself. And in fact, I'll show you what the operators. So this is just the sort of log file of the operator. Actually, no, I lie. This is the config map. So you can see at the top of this config map here, you've got the, this is the configuration. This is the sort of bit that tells the operator, this is what I want to watch for in my Kubernetes API, what events I want to watch for. And then the rest of this bash script is basically reading the details of the Helm file, and then finally it goes and executes it at the bottom. So my bash, by the way, is not necessarily awesome, but it's, good enough. So that's kind of that side of it. And then when you look in the actual, if I go back to my Argo CD dashboard, you can see that I've got the Bootstrap application. So that's the actual application that I was talking about. And in it, you can see that all the application consists of here is these 5 different application, sort of child applications. And so if I go into the Cert Manager one, for example, you can see that there is just what the CRD itself looks like for Cert Manager, for the Cert Manager application CRD. And if I come out of that, and then also you can go into, and this is all of the resources that Cert Manager creates when it gets installed into the cluster. So that's basically my way of automating getting from a vanilla cluster over to a ready-to-go cluster. There is a final bit that I had to do in Terraform, which is something needed to install that Helmfile operator in the first place. There are other ways of doing this, so I tend to use something called Spacelift as my mechanism for running my Terraform code, and that has hooks that I could have used, but in here, what I've done is use the Terraform's kubectl provider just to execute some very basic raw manifests that install the original operator into the cluster. So I have cheated, I suppose, and used a bit of Terraform. But yeah, so that's pretty much the end of my Helmfile walk into a bar presentation. So if you've got questions, then I think we've probably got a few minutes for questions, but many thanks for listening.